Bismillahirrahmanirrahim. So today we will talk about three different things. Last time we did a problem. We solved one problem, and today we're gonna talk about displacement, velocity, and acceleration. If I remember correctly, last time we discussed velocity. So I just want to go through some basic understanding of what is displacement, what is velocity and acceleration, and how it looks like when we plot it out. So let's first talk about displacement. This is the first thing we'll talk about, then we'll go into velocity and acceleration. So imagine you're standing someplace here, right? And you want to travel from one distance, one place to another. Let's say point A to point B. Now, in simple terms, if we just, let's say, draw a coordinate system here. So this is, let's call it Y, this is X, for example, right? That's typically, some, our starting point is 2D, right? Let's call this, so the displacement here, when you went from point A to point B, is this right here is your total displacement, right? And that we'll call it delta X, okay? So, and it could be anywhere, right? So even if you had a plot, just let's look at another example, right? If you were going from here to here, right? Your displacement is from point A, let's call it A prime and B prime. Its displacement here is this, right? Okay, it's not from origin to all the way to the B. It's actually from point A to point B. And the way we represent the displacement is, call it delta X, right, equal B minus A. All right, or in other terms, there's other terms used. Let's call it, let's give another example here for displacement. Is if you have a plot here, you have point, let's call it x1, right, because we're looking just x distance here for now, and let's call it point x2, and you'll see this often in many books where delta x is equal x sub 2 minus x sub 1. So this is basically your displacement, is how much distance have you traveled, right? So keep that in mind. This is displacement, and later on we will discuss how does it relate to velocity, right? And then it'll tie into your acceleration later on, so we'll go step by step. We'll look at all three plots. So now that's displacement. Now what is velocity? Okay, so velocity, as we all know, is how fast someone is going, right? How fast something is traveling. That's what you call velocity. So velocity is represented as v. Okay, now right now typically we'll, for our case right now, we'll just make it simple. We'll just talk about average velocity. Average velocity represented with a bar on top, so that's what we call average velocity. So what is average velocity, right? So average velocity is equal time, distance travel. So you have, again, tying back to this equation right here, right? So because in this case we were only concerned about the distance, how much distance we have crossed, right, traveled. We were not concerned about time. It was just measurement of distance. In velocity, if you probably heard it in miles per hour, how fast the car goes, or how fast the airplane travels, or ships, how fast they travel. So it's related to time, distance covered over time, right? So now first you have to have the distance, which is x2. You need to know how much distance you have traveled, right? But then the velocity part, to make it velocity, right, you have to consider how much time it took. So it's t2 minus t1. So this is basically, if you convert it, right, this becomes delta x over delta t. So that is your velocity, right? So This will tell you how fast on average something is traveling, whether it's your car, airplane, you name it. But this is a basic function, right? It's your delta in displacement versus delta time, how long it took to cover certain distance. So here, just to give you a quick example, right? So let's plot something and see if we can you know see what we can do an example, right? So if you plot something and you choose origin to be your, you know um, so let's pick origin. Well, let's give it a names first. So let's define this. This is t's time, and this is s distance. All right. So your initial x1 and t1, let's call them both to be an origin 0 0, right? So if you have that, and now anywhere you go, you come here, you get t2 and x2. Well, your anytime you reach this position, right, then that basically becomes x is equal velocity over time, right? Because if we do this, just just to show you how we got this, so it's x2 minus x1 over t2 minus t1 equal velocity. Well, in this case, it's just simple velocity, right? So that's zero, that's zero, right? So it's x square, x sub 2, t sub 2 equal velocity. And now you convert this into the equation here, which basically gives you x2 equal vt2. All right. So that's how the function of velocity works. Now, next thing, we'll talk about acceleration. Okay, so what is acceleration? A lot of people get confused between acceleration and velocity. So imagine if you're in a car and you're just starting to pick up and you feel like you're getting sunk into the seat. That's where your acceleration is, because once you know that acceleration stops, you still have a velocity. Your speedometer is still telling you're going 40, 50 miles per hour, um, but you don't feel the force on your body, because now it's a constant speed, uh, but there's no acceleration or deceleration. So it's basically the change in velocity over time. So how velocity is change of distance over time, acceleration is change of velocity over time. So now let's write it down how what it means. So acceleration, right? So average acceleration is, if it's change of velocity, it's going to be v2 minus v1 over t2 over, oops, let me rewrite this. v2 minus v1 over t2 minus t1. All right, so now let's plot some of these plots. So let's see if it makes sense if we plot these three things. So let's first plot distance curves here. Okay, displacement curves. So let's say this is t and this is x. Okay, now if you have this, let's say for example something is going up and then it's coming down. Okay, now remember, this is time versus the distance. Okay, so you have what, first think about this. If I'm going up, this curve is going up, what does it tells me? And then it kind of tapers here, kind of stops, and then it comes down here. What does it mean? So if, can anybody guess what's going on here? Are you moving right or left? Are you moving fast? you're moving slow. What's going on here? So right here, you're moving right? So as the time goes on, so if you consider x to be positive in this direction, right? And this is negative x here, an xy chart, right? And this is positive x. So if you're going positive right here, so what's going on? You're going right, but look at the slope. It's not that steep. So what's going on? You're moving fast or you're moving slow? So you're moving slowly, right? So you're going slowly, first of all, because of the slope, right? Okay. And then secondly, you're going towards right direction. Okay. Now, when you have a taper line here, let's say a straight line here, what's happening? So basically, your time is passing by, but you're not traveling either left or right of x direction. So what does that mean? It means you have stopped, right? Because there's no movement in direction over, let's say, this period right here, right? So this is delta t, but you're stuck in the same x direction here. There's no movement. All right. Now this thing is coming down really fast right here compared to this slope, right? So comparatively, this, if you're riding a car or you're walking here, are you going faster or slower than when you were doing here? Since the slope is down here, see this delta t here, the slope versus x, you're going faster, right? Because you have a steeper angle, right? And then are you going right or left as you're going along here? So you see here, if you were x here, this x is much higher than here. That means you have gone to the left side of the curve in this direction. So you have gone left. So that's our displacement plot, right? So that's one. Let me just write displacement. Okay. Now, next thing, let's look at one more example of, I just want to expand on this because I want you guys to understand this. I've seen a lot of kids having issues understanding this plot right here. Let's say if you f x and t plot. Okay. Now let's say, let's make it simple this time. So we have, let's say 45 degrees here, then line here, and then it just drops like that. Okay. Okay. So once again, let's plot it in nx and y direction, right? And here. So from here to here, I'm moving in this direction, right? I'm moving in this direction. That's the x plot, right? Okay. So let's say this is A to point B, C, and D. Okay. So this is A to B. Now let's look at C, B to C. What's going on here in X direction? So let's say you were somewhere here, right, in X. All that time from B to C, you didn't move. As the time passed by, you didn't move. So you basically, in here at least, you travel this distance, right? In here, all that time, you just stayed there in X direction. You just stayed in that one point, right? So your T changed. You have delta T right here, right? You have this delta T, but your distance did not change. So you were basically stopped. You were at, imagine you were in traffic, right? So you were driving your car here. You see a red signal, and you just stopped for this period right here from B to C. That's where you at, okay? And then let's see what happens from C to D. Let's make it easier. I'll just plot it here. So from C to D, right? You have a very steep stop, right? I mean, sorry, steep angle here. So that means what? Your acceleration was, you were going fast. But from here, let's say you were X here. This is your X direction, right? So this is, let's say, your C stop right here. Your D is actually, you went backwards, right? You went backwards to almost to near zero. So that's your D. So compare to A and B, you were moving in right direction, right? You were moving in right direction. But in C and D, you actually went backwards. You went from right to left, but a very high speed because this curve is very steep. So basically, going right, slow speed. You made a stop here. Sorry. So going from A to B, you're going right at slow speed comparatively from C to D, right? And from B to C, you were at a stoplight. You stopped. You didn't move. There's no distance covered during this time, and then you move backwards, all right, in X direction. So you went from C to D in different direction. So this is our displacement plot. All right, so next thing we'll talk about is velocity. So let's look at velocity curve here. Okay, and let's try to understand what this thing's saying. So this is T, and this is V, velocity, right? Now let's start with our, we can start from origin. So we're going up, 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 we come up, and then we kind of came down here. Okay. So now remember, this is velocity over time. Okay. So what's happening here? Can you guys tell me what's going on here in this region? What's going on in this region? And what's going on in this region? So let's call it region A, B, and C. Okay. So imagine you're standing somewhere, your car, all of a sudden, you have a green light and you hit the accelerator, right? What happens? You start picking up speed. So what's going on at A? Is you're speeding, right? You're speeding. Okay. You kind of, you're building up your velocity. Now what happens at B? B. Remember, right? I told you when you feel the acceleration and your car starts moving, but you don't feel the acceleration, but you still have a speed, right? So what's happening there? And you have a constant speed, right? And that's what's happening when you look at B here. You still have velocity. You have certain velocity, right? But you're not accelerating. You're not accelerating in here. So whatever velocity you have, let's say you have reached 40 miles an hour, and that's what you want to stay here. So that might be here that you're just staying at 40 miles per hour. You're not accelerating and increasing your velocity, or you're not decelerating and decreasing your velocity. You're just staying at that constant speed. Now, when you come down here, it's just the opposite, right? So you have a positive flow. That means you speed, you're accelerating, right? And you're speeding up. And what's going on here? You're slowing down. So C is slowing down, right? So as the time passes by, you see a red light coming up ahead, and you hit your brake, and your velocity, you see in your car, your velocity is kind of what, 40, 30, 25, 20. So that's decreasing. So again, when you're looking at velocity and time curve, positive curve, you're speeding up. If you're constant line, you're not accelerating or decelerating. You have a constant velocity. And then when you see, you're slowing down. All right. So that's velocity. Now let's look at acceleration. So when we look at acceleration, A, and then we look at against the time, right? So now you see this curve, and then later on we'll see maybe this curve, right? So you're driving your car, and this is what's going on. So now let's see what this mean when you have this right here. Let's break this into two segments, right? So what's going on here? Think about this. Per time you're accelerating. So what's going on in here? So let's see on a red light. you hit your gas, and guess what happens? You start to. This is this is more than zero, right? Because right now you're more than zero, so all of a sudden you are accelerating, right? So it's more than zero, so you're increasing your speed, right? Okay. Then what happens here? All of a sudden you're decelerating, right? So a is less than zero. Is still more than zero, but you're still decelerating, decreasing, right? Now in here, let's break this down here. Okay. So what happens here? So a is less than zero, and that's what you're doing. You're decreasing your acceleration, right? Okay, and here from relatively from here to here, see, that's why we're dividing this into here. What's going on? A is less than zero, however, it's going up, right? So you're doing what? Increasing. So you're increasing your acceleration is increasing. So in both cases, and you have to kind of think about it physically what's going on, right? So you're going from point 1 to point 0, and your acceleration is increasing, right? Right here. Even though you're in positive region of acceleration, but guess what's happening here? Your acceleration is decreasing, even though you're in the positive region of acceleration. And same thing here. Even you're decelerating here, sorry, your acceleration is in negative, and you're trying to even decelerate even faster. Versus in here, you're trying to decelerate slower. That means you're trying to increase your acceleration. So you have to understand these slopes. What does that mean? So that's basically the main three things I wanted to discuss today. Tomorrow we'll do some more equations. Thank you. Bye bye.